Okay, today we'll talk about the uses of silver, and we'll also talk about slightly about some uses of copper. Now, of course, silver was known even before Sumerians, but we have the only written documents about silver from the clay tablets of Sumerians, and we see that they named silver as Ku Babar. Ku means pure and Babar means white. So pure white, they meant silver. Now, it was very valuable in Mesopotamia and also after Sumerians in Ottoman Empire, Roman Empire, in many civilizations, silver was very valuable, and we'll see later on that it was used as money. It was more valuable than in some cases than gold. Now, we have many written clay tablets about silver from the documents that we received from excavations of Sumerian cities. And we see that it was so valuable that there were certain people who were trusted people, just like courier. They were allowed to carry silver, not everybody, because they had some trusted men. If they had to transfer silver from one city to the other or from one shop to the other, only the trusted man, the silver carrier, could carry it. So there is a word special for that silver carriers, or in Turkish, courier. And another important person was the person who weighed the silver, because when you have something valuable, you can always be cheated. So how are you going to learn the value of the silver? Only by weighing. So for weighing, you have to use a balance, terazi. But you cannot trust the balance of everybody, because you can always be cheated. Therefore, when you wanted to buy or sell silver, you invited the man who carried his balance, and he was a trusted man. Of course, he charged some, perhaps small amount of money for weighing your silver. So both the person who sells and the person who buys the silver trusted that man. So he weighed the silver. He says, okay, you have 15.3 grams of silver, or not shekel, let's say, and then you bought it or you sold it. So this is the first civilization, perhaps, that we see somebody who is trusted man who carries the balance. And we see that they kept the silver in various forms. One of them is in ingots, külçe, they call kusru. The other one is lumps, like topak in Turkish, it's called siburtu. And also as plates, foils or plates, it's called kapu. So they carried silver in these fixed forms, not in all forms, but if you wanted to buy either foil or in other form. Sometimes also in wire form, sorry. We see that, of course, in the written documents around 4th millennium BC, around, let's say, 3500 BC, that they were using, buying and selling it, and use it in various. But in Mesopotamia, there were no mines of silver. Even today, they don't have, as far as we know, no silver mines. So they imported from Anatolia and also from Iran. We still have some silver mines. Now, as I mentioned before, it was very valuable and it was used as money, just like barley. You recall when we talked about barley, they paid the salaries of working people or the government officials by barley or in silver. If they didn't have enough silver in the treasury at the moment, they paid it equivalent of silver by barley again. So both were used as money. And after Sumerians, in all countries, during Roman Empire, Ottoman Empire, during Selçukis, and in many European countries, silver was used as money. But we'll see how they made it money. Now, of course, when somebody gave you a piece of silver and said, this is money, you would be tricked. You wouldn't be able to trust the man, whether it is something to be trusted or not. Then the kings decided that if they had a small piece of silver, let's say something like this, they put a stamp on it. So you could trust when you saw the stamp of the palace of the king, then that you would be sure that this is pure enough. But we will see later that kings were also cheating the people by reducing the amount of silver, and they were adding some other metals like tin or zinc or whatever. We'll see. But that stamp was important for people to trust, and they called it gin mark. The stamp was called gin mark. In early times, everybody trusted the stamped or gin marked silver, but later on, the kings started to cheat them. Many people did not accept gin-marked silver because they suspected that the amount of silver was low in that stamped silver, which was used as money. It happened in all civilization. During Ottoman Empire, when the Padishah was about to go to a war, he needed lots of money, so he collected gold and silver coins from the market, and then ask people to melt it, and then add more copper and more tin or zinc, whatever, and then print out gold and silver with much smaller amounts than expected. If you recall, I mentioned something about the Romans. During the war, they increased the tax of salt, and then after the war they reduced it. So during war, all the kings needed money, so in some cases they cheated. Now, some people say that since Sumerians put a stamp or gin mark on silver, it could be considered as money in the same definition as we have, but it's not actually true. Many historians do not accept this as a real money. It was used like money, but in modern times, when we talk about coin is something usually circular. In some cases it was perhaps rectangular, but 99% of the time it's circular. On one side, you have the impression of the king, right? Or Padishah, and on the other side, you see the value of the coin, like today. On one side we have Atatürk, and on the other side we had value. So this is the first original money structure, not this one. But some archaeologists say that no, this can be used as money, but it's only a matter of different definition. The first real coin we see was produced in Izmir, Lydian civilization, and they produced the coin by using a gold alloy, which they call electrum. But many years ago, when I went to the Museum of Anatolian Civilization, Anadolu Medeniyetleri Müzesi, I saw that they had the coin there, silver coin, and they said electron. It's not electron, it's electrum. Electron is something else, as we know. But unfortunately, the director of the museum somehow decided to write it as But also in some books, I see that they use the word electron for the alloy of silver, but it's actually electrum. In literature, it's electrum. So this is the coin, the first coin in the world, minted or produced by Lydian people, and it's a mixture of gold and silver, gold alloy, silver alloy. So from then on, all the civilization, even today, we use a similar coin. Now, since the kings, in many cases, cheated, the people did not trust the coins of kings, and they started to melt the coins, which they suspected, even gene-marked coins, and then they purified it. But the kings prohibited the people to melt the coins which are gene-marked. And the king says, if you melt silver pieces which have gene mark, you will be guilty of crime against the government. Because the king does not want you to learn that he is a cheat. He's cheating you. But of course, people still didn't trust the kings. And we see a tablet found in a shop, and the shop owner wrote on the wall, on a clay tablet, saying that government stamped silver is not wanted. We accept pure silver only. So he says, if you want to buy something from my shop, please don't bring me the gene-marked king's coin, bring me pure silver. So you can see the prestige of the kings in those days. And in a first millennium tablet, it says, the God sent me 20 shekels of silver. Only 3 shekels was fine quality. The rest of it was gene-marked. See, the merchant was not very happy because he sold something and he received some money. And just like today, we say, Allah'a şükür, işte bugün işte Allah bereket versin. Similar expression, it says, thanks God, he sent me 20 shekels of silver. But, he says, only 3 shekels were real silver. The rest was gene-marked. So he was not happy. And they had various ratios, official ratios on silver. Of course, you don't use 100%, 99.9% silver, but there is a limited amount that you can add alloy, but that's known by the people. And usually, they sometimes put a mark on it indicating the purity of silver. Same for gold. And usually the ratio was 7.8, 9.10, 8.10, or 11.10. But you can see that there is small amount of another metal in silver coins or silver pieces. Now we see that the goldsmiths and silversmiths always kept good records of their commercial practice when they buy something, when they sell. When they buy silver, when they sell silver, they always wrote down the details of the sales. One of them, it says, 25 minas, 22 shekels of silver to be smelted, that's pitaku, means smelting. 25 shekels were lost by smelting. 24 minas and 57 shekels of silver were given to the such and such person or jeweler to work. So you can see that they write everything down, which also tells us about the purity of gold. And it also tells us that when you smelt it, you lose some of the silver. So can somebody make the calculation here? This is easy, but can somebody tell us whether this calculation is correct or not? Deneyebilir misiniz matematiksel olarak? Adam doğru mu yazmış? But all you have to do is that you have to remember that 1 mina is 60 shekel, that's all. The second one is very simple because he had 34.5 minas. and 1 mina was lost, therefore you only have 33.5. But this one, you have to do just simple calculation. Sistem 60'lık olduğu için, 10'a dayalı olmadığı için bir tane minayı alacağız, 60 deyip şeker ekleyeceğiz değil mi? So we have here 25 minas, 22 shekels. That's not enough for us to subtract it, since 25 is bigger than 22. Therefore we take one mina here, that will be left as 24 mina. It will add 60 to this, it will be 82 shekels. And then when you make the subtraction, so the man's calculation, doğru çıktı değil mi sende de? His calculation was correct. In some cases, calculation comes out to be wrong, but in 99% they do the right calculation. The second tablet says, we talked about it. It's not something to discuss. It's very simple. Now, sometimes they mixed pure silver and impure silver when they are going to produce a jewelry. So in this one we see that they say 42.5 minas of refined silver and 2 minas from the deposit. So it means that the man had 42.5 minas pure silver and then 2 minas from the deposit that's not very pure. So it mixed them together and then smelted it. 44.5 minas of silver was obtained, 1 mina is lost. So we see that they do this to send it to jeweler before they send the mixture. Usually we understand that jewelers did not smelt it for purification. Usually they prefer to get the pure silver and then they added some another metal when they produce. But usually they have jewelry, not only 100%, but they always had some amount of, if it is gold, some amount of silver. If it is silver, they had some amount of tin or zinc perhaps. Now, in some cases, if you are lucky, you can find silver ingots in metallic form, but it's very rare. Usually, you find them in mines where they excavate lead carbonate or lead sulfide. The majority, of course, is lead, but you have about 1% or even less amount of silver. Gold is the same. It's very rare to find gold in pure form, in metallic form. Usually, you have to dig other mines where lead, zinc, when you have some heavy metal like lead, which has density close to silver and gold. Usually, those mines contain small amount of silver and small amount of gold. That's why it is very difficult to purify gold and silver. That's why the price of course, amount of gold is much less than silver. That's why that determines their prices. If you have something very little amount, the price goes up. If you have large amount, the price goes up. So the price goes down. So they were able to purify even less than 1% silver, and they would obtain pure silver. But of course, in those days, technology was not as well defined, as well developed as today's technology. As technology developed, people tried to was also producing silver, even let's say 0.3 or 0.4%, much less than 1%, because they reduced the cost of production by using high technology. So even Sumerians, as they developed the technology, they tried to produced, not Sumerians, they didn't have mines. I mean, Anatolia or Iran, the people produced silver from mines which contain less than 1. Now, also when they carried silver or used it in commercial activities, they kept it in various forms, like 1/8 shekel, 1/2 shekel, or 1 shekel. So when you bought something, it made it easier to exchange it. These are the main ratios, but in some clay tablets we see that they use different ratios as well. But these are the most common. Now, we see that copper was also important in Mesopotamia, because they produced bronze by mixing it with copper, mixing copper with zinc and tin to produce bronze. The ratio of copper to silver, that is actually the price. So when we have some clay tablets which tells us that the ratio, if you wanted to exchange, say, gold or silver or copper, the ratio was fixed. But it again varied depending on the inflation in the country and depending how trusted the king was. But in general, we see that in Hammurabi time, it was like silver to copper ratio was 1/140. That means you had to give 140 shekels of copper to get 1 shekel of silver. You had to give 6 shekel of silver to obtain 1 shekel of gold. Or in the previous one, it was like 1 shekel was 112 shekels of copper. It varied from 112 to 140. As I said, it varied depending on the purity and also the attitude of the king, and also inflation. Inflation was always there. Inflation was not the problem of this century. It was always there, inflation, because it depends on the total production of anything in the country, total production of barley, total production of silver, total production of some fruits, etc. If you produced much less barley than the previous year, of course, the price of barley goes up almost 2 times. So that's inflation, you see. So it happened many, many times in Sumerian civilization as well. Now, silver, as I said before, was used and exchanged just like money. And in some languages, money, we'll see later on, the money and silver were the same. They use the same word for silver and money. And all civilizations, Roman Empire, Ottoman Empire, or Seljuk empires or kingdoms, they used silver to produce coins. And you can see a Ottoman akçe, silver akçe, both sides during Orhan Gazi, perhaps one of the first minted yani para bastırma para basılan yere ne diyorduk? Darphane. Darphaneden çıkış, darphanede basılma, minted. Piyasaya sürmek için basmaya kastediyoruz. Now, as I said, they use the same word for silver, and even today in modern times, in French, money and silver are the same. They call Argent, nitrat d'argent. You see sometimes when you get silver nitrate from the stockroom, it's a nitrat d'argent. Also in Hebrew, kesef, it means silver and money boats. And in Mesopotamia used to call kaspu. So in Hebrew it's slightly changed. Kaspu and kesef, similar. But of course French it's quite different. The reason they call Argent, anybody knows, does Argent, the word, make you recall something, a country? Argent? Argentina, because silver came from Argentina to Europe. And they call themselves Argentina because of silver. We don't know which is older. Okay, well, anyway. So we see that in Mesopotamia, they said, Anakaspi nada'u, meaning to sell. And Anakaspi maharu means to buy. So they use these two expressions for buying and selling silver. Now, like in modern times, many governments try not to tell, I shouldn't say lie, but try not to tell the truth to the people about inflation. It was the same there. Assurbanipal was lying, actually. We can tell that he was lying. He cannot take us to the court. He was lying to the people about inflation. He says, May Assurbanipal, king of Assyria, it's a hymn, ilahi, kendisi için bir ilahi besteletmiş. May Assurbanipal, king of Assyria, be agreeable to the gods. Yani Allah tarafından kabul görür inşallah. İşte herhalde cennete gideriz vesaire demek istiyor. May the people of Assur buy 30 cores, about 5,400 liters of grain. Of grain for 1 shekel of silver. 1 shekel of almost 5 tons. And it's not true. We'll see later on the real prices. One shekel of silver, you can buy 5.4 tons of grain or liters of grain. May the people of Assur buy 3 seah, about 18 liters of oil, sesame oil, for 1 shekel of silver. 18 liters for 1 shekel. Even for today, it's very cheap. May the people of Ashur buy 30 minas, about 15 kilogram, of wool for 1 shekel of silver. But that wasn't true. We'll see. Now, you remember the relief or the carvings, rock carvings of Assurbanipal. But you notice that this time the arrow was carved correctly. But you should notice these 2 pens. You see, in other ones he was on the other. He was facing the other side. Still, it was here on there. So they always wanted to prove or show to people that this Assurbanipal was educated man. He knew how to read and write, because all the other kings in Mesopotamia never read, never wrote. They didn't know anything about reading. They made the propaganda that he was the first or the only king who knew how to read and write. Educated king. Now, Nabonidus, I didn't mention about Nabonidus, but later on I will talk about him. He is the first archaeologist. He is supposed to be the first archaeologist in the world. And he also lied to people. He says, at the command of the Sin, moon god, the king of the gods, Adat, weather god, release the rain for me. Rahmet çok yağdı demek istiyor, yağmur. God of sweet water, open for me lavishly his sources. Yani bana çok böyle şey davrandı, cömert davrandı. Wealthy, fertility and plenty he established in my country. 234 liters of barley for 1 shekel. 270 liters of dates, hurma, for 1 shekel. 66 liters of sesame for 1 shekel. 18 liters of oil, sesame oil, for 1 shekel. 5 pounds of wool for 1 shekel. 1 pound of tin for 1 shekel. Wine, the beer of mountains. Ağaç şarabı diyorduk ya, burada da dağ şarabı diyor. Dağdaki, yani üzüm tabii dağda da var. 18 liters of wine for 1 shekel of silver was exchange value in my country. But this is the carving or relief of Nabonidus. It was found in Urfa. Var mı Urfalı aramızda? Arkadaşınız vardır nasıl olsa. Onların müzesinde duruyor. Okay. But the real prices were more than twice the prices given by Asurbanipal, and at least 30 to 35% much more than what was declared by Nabonidus. Now, we see, because of the inflation, how some normal people became very poor. There's a tablet which is found in Sultan Tepe in Turkey, and we see that the man had a normal life, but later on, because of this inflation, he was begging. He was so poor. He says, there was a man, a citizen of Nippur, destitute and poor, yoksul ve fakir. Gimil Ninurta, his name was Gimil Nimurta, was his name. Unhappy man in his city Nippur. He lived working hard but had not the silver. Befitted to his class, yani kendi statüsüne, kendi çalışan bir işçi statüsüne uyacak kadar gümüşü yoktu diyor. Had not the gold befitted the people of his statue. Gene benim klasıma uygun altınım da yoktu diyor. His storage bins lacked pure grain. Bütün ambarlar boştu, hiç içinde tahıl yoktu. His inside burned, craving food, and his face was unhappy, craving meat and first class beer. İçim yanıyor açlıktan, içim kavruluyor. İşte biraz güzel bira olsa, biraz et olsa, derdini tek tek anla. Şiir tabii bu. Was dressed in garments that had no change. Üstü başı yırtık pırtık, yeni elbisesi de yok değiştirecek. Hep aynı elbiseyle geziyor. İşte bu haldeyiz diyor. Tabii bu da herhalde krala bir gönderme kibarca. Anlayana olmuş o zaman. Yani çünkü kral böyle diyor. O her şey bol, her şey ucuz. Adam diyor ki biz çalışıyoruz, uğraşıyoruz. Yani işim de var diyor. Ama diyor işimden aldığım bana yetmiyor. We see this word demgar in Sumerian tüccar and tam karum. Karum, karum çarşı pazar satış yeri. Karum bugün de diyor karum marum oradan geliyor. Tüccar in Akkadian language. Now we see that they use silver in various forms as jewelry, and also the rich people, the kings and queens, they used various equipment made out of silver. So this is a silver pouring water, just like hamam tası, but of course for the kings, not for the ordinary people. We see that there is an 8-pointed rosette in the. It's a special symbol. I don't know. Maybe later on we'll talk about it. It's small. It's about 10.3 centimeters. Probably it's for ritual or religious ceremonies. Hani yağlı suya çocuğu batırıyorlar, yıkıyorlar vaftiz gibi. Öyle bir büyük bir ihtimalle öyle. Çünkü o kadar küçük bir şeyle hani hamamda yıkanılmaz ama hamam tası şeklinde. This is another silver vessel for pouring liquids around 2500 to 2900 BC. This is from the Royal Cemetery of Ur. It's again 16 centimeters. It's a small one again, not even much less than 20 centimeters. All ceremonial. Silver was not only used for jewelry or some tools used at home. It was also used for helmets and also some war equipment. And here we see that this is about 24 centimeters to 19 centimeters, and it weighs about 1.64 kilogram. And it's made out of silver, bronze, and iron, and it has some silver pieces. It was found in Iran. So silver, bronze, and iron pieces, but it's decorated with silver. Now, this is again a ceremonial vessel. You see the bull is just like human being. If you just look at the bottom, it's just like human being. Just the head is bull, rest is like human on his knees. Yani diz üzerinde Tanrı'ya dua ta o zamanlardan geliyor. Yani Tanrı'ya saygı her zaman diz çökerek, bütün çoğu şeyde öyle. Now let's talk about silver in our modern times. Now, does anyone know anything about RFID? RFID? Radio identification. So we use it in our cars, in libraries, everywhere. And this is a small photograph of it, and we can take advantage of this identification chip, let's say, even we don't see it. Even it's far away from us, we can still be recognized. And of course, silver is very important material used in RFID identification tags. Now, at very long distances, we can still get signal. Because this RFID tag has very small, very tiny radio receiver and transmitter. Of course, you cannot listen to the radio, but if it receives a radio signal, it's triggered, and then it responses. Suppose that you are carrying in your ID, and then you are passing through a door, and there is a certain equipment there. That equipment sends you electric fields, and that triggers your RFID tag. It receives the radio. It knows that you are they are asking your name and number. You see, and it answers in the radio. Says, I am Ural AKBULUT. My number is 536. Then you can pass. But you don't use energy there. You get the energy from the electric fields of the control panel. But we wouldn't be able to produce this RFID tags without silver. Silver is the important ingredient of these materials. Now, did you ever hear the word silver paste? Gümüşlü macun mu diyelim? Or silver ink also. Silver ink or silver paste, they are the same. Duyduk mu öyle bir şey? Ama tabii evimizde kullandığımızda ilgili değil. Nasıl inkjetlerde? Olabilir.
Böyle taglerde olduğunu biliyorum.
Tamam. So you have to use very small amount, very small particles. That is nanoparticles of silver. Then you can mix it with some solutions, and then use it as in printers, inkjet. If you are going to print a circuit like this, so inkjet draws this one, the solvent evaporates, and then you have here some silver line. But of course, you have to have some polymer to make sure that sticks there. Sometimes you use the paste. That means you have nanoparticle silver metal, silver nanoparticle, metallic silver. You add some solvent, and then you add some polymer, like ethyl acetate solution and a polymer. Then you can arrange the amount of polymer and the amount of solvent, so you can produce a paste. That paste, you can actually draw lines. You can draw lines with that paste, because immediately the solvent evaporates and you are left with a conducting line. So if you have an electronic device, let's say you have here a resistant, and then here you have maybe an amplifier, you can use this paste to combine them for electrical contact. The paste, instead of using silver metal melting, this is much easier and safer, because you have to heat it to melt the silver solder. If you are going to solder with silver, it's dangerous to use them in very small RFIDs or other electronic equipment. So silver paste is very valuable, very easy to use. Therefore, you need to produce nano silver particles. And can anybody suggest a method how to produce nano silver particles? Anything that comes to your mind. O kadar zor bir şey düşünelim. Yani şöyle olsa iyi olur diyelim. Any idea? Of course, you are not going to send it because they are not nanoparticles. You have to have very small particles. No suggestion? Now, if you use a proper silver compound, and then somehow, if you find that method to convert that compound into metallic silver, to reduce that silver ion, silver plus, if you have a compound, silver plus, say, nitrate or whatever, then if you use the proper chemical to reduce that iron, silver plus to metallic silver, then you obtain very small particles. That's how they do it. Oh, I forgot to mention about the ultra-high frequency. Ultra-high frequency identification tags are used for trucks transporting things from Ankara to Istanbul. Then you can track them. That's why they say ultra-high frequency. Similar technology. Since it's ultra-high technology, you can track them wherever they are. By radio signals. As you know, radio signals are electromagnetic waves, and if you play a radio in United States, you can listen it, if you are lucky, in India. It travels around the world. So the signal reaches to the other side of the... How does it happen? Electromagnetic waves can travel around the world. Because normally we would expect that if this is a radio station, if it emits, well, I expect it to go directly. Because normally electromagnetic waves, they go straight ahead. Like the light coming from the sun comes directly, it doesn't bend. But radio waves goes around like this. Bir fikir söyleyin canım, o kadar zor bir şey değil yani, hani bulmaca gibi sormak istemem. Any idea? Huh? Yeah. The electromagnetic field of the world bends it. Electromagnetic waves are sensitive to magnets. You can bend them. So that's the way that we produce many electronic devices. Therefore, if your truck travels around the world, doesn't matter. You can still, of course, there is a limit. I mean, this is an exaggeration. It's very hard to listen, but we were able to listen radios from Europe. I'm sure that if you have a proper radio, you can listen to the music from Sweden or England. Well, anyway, so this technology is possible because of silver, nanoparticle silvers. And silver is very important in electronics, in high technology, because when you solder some electronic parts, you have to use gold or silver to minimize the resistance. Any electronic part that you solder together, of course silver is much cheaper than gold, but at very high technology chips or tags, they use gold for soldering. In many cases silver, but in some cases they need to use gold to minimize the resistance because of after soldering. Lehimleme. Now, in silver paste, usually you have silver, palladium, nickel, copper, or even carbon. So depending on your need and your technology, you can use some of these elements in nanopowder form to produce your conducting paste which you need. So you can easily make it. You take a polymer, dissolve it in solvent, add some powdered silver. We have in our laboratories, silver powder is not too expensive. You can make your own paste. Sometimes, I don't know if they still, arabaların anteni arka camda olurdu. Bazen kopar. Ona yapıştırıcı hiç öyle bir şey gördünüz, duydunuz mu? Küçük satılır böyle. Oje gibi sürersin, o anten çalışır. Başınıza gelmedi. Neyse, gelirse yaparsınız. Anten arkada, hatırlıyor musunuz? Arabanın arkası şöyle şey vardır, anten. Kopar bazen. Adam silerken bir şey olur. Kopar, kopunca çalışmaz. Oraya azıcık silver pasta sürdün mü çalışır. So silver paste is used in all of these technologies, in printed circuits, in supercapacitors, in hybrid cars, everywhere, in special batteries. Yeah, as I mentioned, you have to use sometimes silver soldering rather than ordinary lead tin. Ordinary solder is lead and tin, right? Normal lehim dediğimiz şey kalay ve kurşun karışımı. Ama tabii onun direnci yüksek, iletkenliği gümüşün çok yüksek, altınınki ondan yüksek. O yüzden yüksek teknolojide herhangi bir direnç karşımıza çıkmasın. Çünkü bağladığım zaman elektrik o kurşun kalaydan geçiyor. Ama ben yüksek teknoloji orada hiçbir enerji kaybetmek istemiyorsam, hiçbir elektronikte değer kaybetmek istemiyorsam, direkt geçmesini istiyorsam ya gümüş ya altın yapmam lazım. O yüzden önemli. So in electronics they use 99.99% pure silver. They have to. Yeah, also in light emitting diodes. Does anyone know what light emitting diode is? It is light emitting diode, how it works? What is the name? Diode. Do you know the structure of diode? What's diode? O kadar zor bir şey değil canım, diode.
Passes currency only in one way.
Yeah. He says, when we talk about diode, the current can pass only in one direction, he says. This is a diode. What do I have here? It says current passes in one way. Only. It looks like this, but of course not high technology, but the big ones are like this. What do I have here? What do I have here? Anybody knows? No? You know what semiconductors are, right? Semiconductors, okay. What kind of semiconductors will we use? P-doped and N-doped. When we say P-doped, that means we have some points which is positive. We have some deficiencies negative. So P-doped and N-doped, when you bring them together, you obtain a diode. P-doped, N-doped, that's diode. It lets current pass in one way. If you use three of them, P and P, transistor. You know what transistor is, what it does? Transistor. Hiç duymadık mı? Transistor. Bir şey söyleyelim ya.
Actually, it charged with the charge capacitor and after it filled with the charge, it works.
But it works what? Does what?
Actually,
We use it for very important purpose.
collecting and utilize the electricity when we use.
Sorry?
Collecting the electricity and utilize the electricity we collect in when we want to use.
No, no, it's a capacitor. Capacitor. Capacitor is something else. This is what? This is made out of insulator. These are conductors, so it's capacitor. It keeps the charge until you need it, right? It's a capacitor. But transistor is something else very important. Without transistors, you wouldn't have radio or telephone. You wouldn't be able to carry your telephone.
Isn't it to convert the alternative current?
Sorry?
Isn't it for the conversion of alternative current to...
No, it's diode. You can do it with diode because the current enters as alternating, comes out as direct current. Because the tunnels go back. Alternating current goes back and forth. If it cannot go only one way, then you can use it to convert alternating current to direct current. Sorry?
Hocam çiplerde kullanılmıyor.
Ne olarak? Tabii kullanılıyor. Çiplerin en önemlisi. Zaten çiplerde resistor, capacitor, transistors and diodes. That's it. Conductors and resistance. Ne oluyor orada? Bak, telefon çalışmaz, radyo çalışmaz. Ne yapıyor ki acaba?
Kapatıp açıyor galiba.
Kapatıp açma değil.
Yok, sıfırlar birler.
No, it amplifies. It amplifies the signal because the radio waves come from the air. We have antenna, but the amount of electricity is so small that we cannot convert it to sound. So we take the signal and we amplify it, then we can hear, right? So amplifier. So in all these electronics, silver is very important. But when you talk about electronics, you should learn these. They are very simple, but it gives you an idea. Oh, okay. It is also used in nuclear energy power plants because in power plants we have enriched uranium. When we say enriched uranium, what kind of uranium? Which isotopes are we talking about? Enriched uranium. What does it mean? Enriched uranium. Biz de daldan dala atlıyoruz. Gümüşle girdik. Atom. Evet, okay. Bir şey söyleyin canım.
238 mi, 237 mi emin ol.
238, evet, so we have uranium 238, uranium 235. There are others, but these are the ones that we are interested in talking about enriching. Which one are we going to enrich to produce nuclear energy? One of the isotopes. $235. So normally in natural uranium, if I'm not mistaken, about 99 point, 90, was it 99? I forgot, I can't remember, just a second, 99.7, yeah, is uranium 238. And therefore it's only 0.67 or so. Probably. Bir bakar mısınız ya, yanlış bir şey yazmayayım tahtaya. So uranium 235 is much smaller. Bir baktım yanlış yazmayayım şimdi.
235 is 0.7 and 2.
0.7
0.71. Actually, it goes like that, and
Zero-
you get 72.
0.712.
19. Actually.
Okay, 72 roughly. This is 3 then?
Yes, hocam.
99.3?
Yes.
Okay, roughly. Or 2.99 or something. Well, anyway, so in order to produce nuclear energy, we need this. So that's enrichment. You remember the stories on radio and television about Iran? They say Iran reached to 20%. That means they can easily make nuclear reactors to produce energy. But the most difficult part of enriching uranium is to go up to 20%. You see, it's 0.7%. It takes many, many steps to go up to 20%. You see, it's very difficult to go to 20%. If you go to 20%, then going up to 40 or 50, much easier. Well, few steps. But here you have to go through many, many steps. That's why Americans were angry at Iranian, because they were saying, well, we are just going to make nuclear reactor. If any country has nuclear reactor by their own technology, that means they have nuclear bomb. It's very easy. It's not only child's toy. It's very easy. Because in nuclear reactors, you need 40%. That's enough. 40, 50. You don't even go up to 50. You can make atomic bomb. So, how do we obtain nuclear energy? We have, okay, uranium-235. So what? What do we do? It was a very important discovery made by, anybody remembers the person who made an important discovery? He was a chemist. He was a German chemist. He discovered with another lady, he was a man, of course, but with a lady, Lisa Meitner, and the chemistry professor accidentally discovered that you could break uranium-235 by you produce many compounds, it breaks apart, but you need something very simple. Neutron. So if you bombard uranium-235 neutrons, you produce nuclear energy. If it is around 15-20%, you produce energy. It gives us heat. But if you have more than 40%, if you bomb it with neutron, it explodes. Okay? Very simple. Anybody remembers the name of that chemist, German chemist? Bakın bakalım. Lisa Meitner'i söyledim. Heykeli var şeyde. Bizim burada mı? Kütüphanenin orada mı? Lisa Meitner burada, kimyada. Yok mu hızlıca bakabilen içimizde?
Hocam sınavı ne zaman olacağız?
Kim?
Sınav.
He?
Sınav hocam.
Az kaldı. Bırakacağım birazdan. Çok istiyorsun sınavı, ha? Peki.
Yok hocam.
Sınav meraklısı bir sınıfa düştük. Bulamadık mı? Otohan. Tabii her zaman olduğu gibi Otohan'a Nobel'i verdiler, Lisa Meitner'e Nobel yok. Ama Amerikalılar da Otohan'ı İngilizler hapse attı. İkinci Dünya Savaşı bitti. Vay sen misin atom bombasının önünü açan? Hapislerde yattı adam. Sonra Nobel'ini alamadı, çıkınca aldı. But he did not make the atomic bomb. There was somebody else who carried out the first nuclear energy production. He was an Italian scientist. He escaped from fascist dictatorship in Italy to United States. No, Oppenheimer was German. O da hapse gitti. Oppenheimer da hapse gitti. Amerikalılar 2. Dünya Savaşı, Oppenheimer da hapse gitti. Italian physicist who produced first nuclear energy. Columbia nuclear pile, Chicago nuclear piles. Chicago nuclear pile, Columbia nuclear pile, Italian physicist. Hadi ya 5 dakikada bulur. Bildiğiniz bir yer. Enrico Fermi. Enrico Fermi was working on uranium and bombarding things like, but he didn't know that he needed pure uranium-235 because he was a physicist. He was bombarding uranium, but he didn't get anything. He didn't succeed. He was suspecting that he could produce perhaps nuclear energy, but he couldn't do it. Then he escaped from, he won a Nobel Prize because of something, another discovery of him. And Mussolini said, if you go to receive the Nobel Prize, don't come back to this country, because his wife was Jewish. And Enrico Fermi escaped and went and received the Nobel Prize. Of course, if he returned to Italy, he was going to go to jail. So escaped, the American FBI helped him to go to the United States. And like many other German, Italian, French scientists, they all escaped to the United States because of fascist regimes. And Americans were very lucky that the top scientists of Europe were there. Then Enrico Fermi started to work on nuclear energy production. He made those 2 piles. He produced nuclear energy. And then with this knowledge and some of the American top scientists, they were able to make the atomic bomb. Of course, we don't know whether production of atomic bomb was good for humanity, or of course it wasn't, but what can we do? It's good for science, but not for humanity. Of course, in those days, they didn't know the harm of nuclear compounds or nuclear materials so badly, because they had many radioactive materials discharged. They put them in big barrels and then they dumped them into the bottom of the ocean. But those barrels, of course, rusted, and all that nuclear material is now under the ocean. They tested the first hydrogen bomb on an island. And I don't think there is still any life in that island. In the middle of ocean, there is an important island. It's a famous name, but they bombed it. But thanks God that all countries were exploding atomic bomb when I was a child. French exploded the first atomic bomb. England, first atomic bomb. Canada, first atomic bomb. It was on headlines. And then, thanks God that finally they stopped. They still produce atomic bombs. Thousands of atomic bombs are existing, but no experiment, only North Korea. Okay. Daldan dala atladık. Okay, there are many chemical reactions where some silver compounds are used as catalyst, and ethylene oxide and formaldehyde are produced because of the silver being used as catalyst, and both are used in technology for making polymers, antifreeze, things like that. And formaldehyde is a very valuable compound for disinfection, and also for mumming, making mummies, and also when you have some, let's say, animals that you want to preserve them, you put it in formaldehyde. Bazen kurbağa görürsünüz, kertenkele müzelerde hepsi formaldehit'te. They don't disintegrate in formaldehyde. Also, in antimicrobial property of silver is very important. If you go home, open up your refrigerator and see that, you will see that it says we have silver, right? Because it prevents the growth of bacteria. In many places we use silver now as, for disinfection and protection against bacteria. And there's a nice property of silver, just like gold. You can make wire composed of one single atom. You can see the picture here. This is, you see the atoms one by one? You make a wire. This was not discovered, I guess, about 5 or 6 years ago. Not very old, very new photograph. I cannot remember the exact date, but it's a new discovery. Gold, we knew that you could do it, but silver, we didn't know. In the old days, we didn't have electronic photography, and we used to make silver emulsions with gelatin, and all the photographs, X-ray photographs, or colored photographs, or black and white photographs, they were all needed silver. In fact, I had 2 master students who worked on photography emulsions, and one of them worked on X-ray emulsions, and the other one on photography emulsions, because Turkey was preparing itself to produce photographic films and X-ray films, as well as air photography films. But in those days, we made various research and projects in METU, but after a while we realized that electronic photography just starting, but it was terrible photographs, high quality, it was terrible quality, but in short time, electronics developed so fast that I don't think we can ever see any var mı any photographic film still, I don't know, var mı hala satıyorlar mı? Some professional photographers prefer still emulsion. It's very easy. You have a solution in gelatin, small amount of gelatin, about 3% or something, water, warm water. You add some silver nitrate, and then you add some silver chloride, mix it. Depending on the temperature, depending on the concentration, you can make big crystals or small crystals. If you have big crystals, you can obtain different photographs with, which is a fast film, but the grains, since the grains are big, quality is a bit lower. But if you use very fine, very small silver halides, then you obtain photographs with all the details like in X-rays, but it takes some time. So posing time is short in big crystals, posing time is long in small crystals. Also in color photography, they had some dyes in there, but the first material which is sensitive to light was, of course, silver. Then during the time of processing, those organic chemicals with colored chemicals produced the colored photography. But silver you always needed because it was the only known chemical compound sensitive to light. Does anyone know anything about electronic photography? How does it work, electronic photography?
The photons from the source comes from the detector.
Yeah.
And detector records the
Comes to the detector?
Comes to the detector, and detector actually converts this photon energy to electron.
Yeah. What is the composition of the detector? What is it?
Detectors are used, I think. CCD detectors.
What?
CCD.
CDC detectors. But do you know what CDC means?
I was
Contemporary or something?
it's a photo detector, but I don't remember the full name of the CCD. Right.
But the idea is that when photon hit, it produces electricity. It goes back to a very famous scientist, photoelectric effect. Who was the inventor of photoelectric effect? If you shine light, it gives out electron. Metals do that. Very well known scientist. Everybody knows, even elementary school students. Huh? Yeah. That's why he received the Nobel Prize. Yeah. Okay. Well, anyway. Gene daldan dala atladık. Okay. So we do not use it anymore. We prefer electronic. Now the wedding rings, of course, we generally use gold wedding rings, but some people prefer, conservative people, somehow they prefer silver ring. That comes from Sumerians. We learned that married people or engaged people would wear rings from Sumerians. But in Sumerians, only the ladies used to wear the ring. Men didn't wear. Married men didn't wear the rings, only the women. Now here we talk about yellow silver carbonate. And when you reduce it, you look at the very simple reaction. Silver carbonate plus formaldehyde, you produce silver. That's your nano powder. You control the conditions, you have silver nanoparticles. Very simple reaction. Now, this compound is important. Silver fulminate, it's touch sensitive. So when you hit it, it explodes. Then you use it in ammunition product, in ammunition. Also, ternary alloys like silver, tin, mercury in dental amalgams, gümüş dolgu dediğimiz zaman, it's the alloy. Of course, we know that mercury is very harmful, but we still use it in our cavities. Silver, mercury, tin. When you go to the dentist, you see that he mixes amalgam and then puts in a cloth and squeezes. The mercury comes out. Excess mercury comes out. Yeah, as I mentioned, conductive inks, etc., pastes. Okay, that's the end. Let's